Classes and objects give you the ability to define and work with more complex models in your programs. When you define a class, you're creating a data type. And what we know about data types is that they tell us what we can do with something. They tell us the shape of something and the attributes of it. So when we have an integer value, we know that we can perform arithmetic with it, and it's numerical in nature. When we have a string, we know that it's textual in nature and that it has string methods associated with it, and that we can concatenate it. Well, often the problems that we would like to solve and write programs to solve have more real-world definitions than that and are made up of attributes that are less generic than integers and strings. So with classes, we're going to be able to model more complex concepts, such as the idea of a Twitter profile or a pizza order, or data records that involve columns of varying data types. A class is going to be how we define the custom type that we're going to be able to work with. In this video, we'll look at how we can use a class to define a grouping of variables, which we'll think of as the attributes of a class. After we've defined a class, or the idea, the template of some new data type, when we go and work with actual objects and instances of that data type, we'll call them objects. Objects, just like dictionaries and lists, are going to be mutable and they're reference types. So we're going to need to be careful with how we think about passing them around as arguments to function calls. To give an analogy to the idea of classes and objects, I think it's helpful to think in terms of services we already know and use. So what is this you're seeing on your screen? Well, you could think of it as a template, a visual template for what a Twitter profile is made up of, right? This is an example Twitter profile where all of the specific fields are replaced with names for what would go in those locations. So there's a name attribute, a handle attribute, biography, location, so on. You can think of this as a class. This is a template for whenever someone goes to register for their own Twitter profile. These are the attributes that they're able to customize in their own profile, which we'll think of as an object, right? So a class isn't actually a visual template in this manner. We'll look at the code that makes up a class in another couple of slides, but you can think of it conceptually as very similar to a template for the types of objects we'll be able to make. What they define are the attributes, or what the data type is going to be made up of, and it's a composite, right? So the analogy that I would like you to take home is the idea of a Twitter profile template is to a specific Twitter profile as a class is to an object. And to try and drive this home, we could think of each of these individual Twitter profiles as objects, right? So each of these profiles has their own attributes, their own values for each attribute, right? My Twitter profile name is different than AOC's, and the same with our handles. We have different bios. And of the millions and millions of Twitter profiles, each has their own custom attributes associated with it, right? And so, or I should say values associated with attributes, but they all have the exact same set of attributes available to them. Notice that these attributes are of varying types, right? So my name is a string. The number of people that are following me is an integer. So how might we actually model a Twitter profile in code? We'll look at the exact syntax in more detail in the next video, but the big idea is we're going to be bundling a bunch of related variables together into their own single data type. We'll call these variables attributes of the class. So for example, class Twitter profile, followed by a colon, and then in the body of this class, we see each of the attributes being defined. Name is a string, handle is a string, show vine, rip is a Boolean, followers is an integer. So our attributes can have their own distinct attribute data types associated with them. Name is a string, show vine is a Boolean, followers is an int. You can use whatever data type you'd like when defining an attribute. And we can think of these as connected to the forms, the fields of a form if we were filling out a form, right? So when you go and you fill out a Google form or an order form, the boxes that you're filling out, you could think of as what the class would be made up of, right? We're defining the template, the things that you can, the various attributes that you can actually assign specific values to. Whereas with an object, it's the actual values that are plugged in. So for me, in my object, my Twitter profile object, it has a string name of Chris Jordan. Each object's attributes are established by the class. So each of the objects shares the exact same set of available attributes, but each has its own specific values associated with those attributes. We've previously looked at dictionaries, which are also a composite data type and allow you to associate a key with a value. So how do classes and dictionaries relate to one another? Well, with a class, your attribute names must be valid identifiers. And remember, an identifier is something like a variable name, a class name, a constant name, a function name. These are all identifiers, and there are rules associated with what's a valid identifier in a given programming language. Like in Python, you have to start it with a letter or an underscore, and it can't contain spaces, things like this. Whereas with dictionaries, when you set up a dictionary, you're defining its key type. And you can use any immutable type for the key. So let's say we used a string type for a dictionary's keys. Well, a string can have spaces in it. So you can have a dictionary whose keys have spaces in it, and that's no problem. And so there's different restrictions around how there's a big difference between attributes in a class and keys in a dictionary. Keys can also be other types, such as floats and ints. Attributes are individually typed. Right? So a Twitter profile's name is string, followers is an integer. Whereas with a dictionary, all of the values that you associate with any given key must be of the same type. When you define that dictionary using strong typing, as we are in this course, we introduce a constraint that when you set up your dictionary, you're specifying what are the type of your key and what are the type of your value. So you have more flexibility and a stronger guarantee of an individual values type. In classes, you can have more control over what an attributes type is. All objects of a class, or all objects of the same type, you could say, have the same attributes defined, right? Every Twitter profile has the exact same set of attributes available to it. Whereas with a dictionary, there's no guarantee that any two dictionaries share the same keys. They might, but that would be because all of those key value pairs were added to both of those dictionaries individually. With a dictionary, there's no predetermined assumption that you're going to have two dictionaries with the same keys in them. You would have to test for that and control potentially for the edge case where that isn't the case. Whereas with classes and objects, if you have an object of a given class, you have some guarantee that it has that attribute associated with it. Classes are really useful when you know all of the attributes of some model ahead of time, and they have different types, right? And so we'll be exploring this in the context of a pizza modeling application or a pizza ordering application. Whereas dictionaries are really useful when you might not know when you write the program, what are your keys going to be or what values will they have? And so with dictionaries, we have a little bit more flexibility at runtime. But you're going to have to do for a robust program, you would have to check to be sure that, hey, does this key actually exist in this dictionary? Whereas with classes, you have that guarantee. So these two concepts are distinct from one another. In some cases, you can go one way or the other and be totally fine. You can write a class that behaves and feels kind of like a dictionary if you know the key or if you know the attributes that you need. And vice versa, you could use a dictionary in some cases where you can use a class. When you're trying to model a very specific problem and you know all of the attributes of the data types that you're hoping to work with in that problem, classes are generally a better way to go about your business than dictionaries. But with dictionaries, you have a lot of flexibility, and you can think of almost as a Swiss Army knife for taking on problems very quickly without having to put in the foresight and forethought of defining a class and thinking through all of its implications. We'll learn some additional things that we can do with classes, such as add methods and constructors that aren't possible with dictionaries, which will make them even more robust and powerful in a lesson ahead. This is a quick introduction to the idea of classes, as you can think of them as structured groupings of variables that we can use in our programs.